All right, so we are going to continue here with our geometric sequences. Now, when we're doing the geometric, wow, everybody's getting further away from me. Hang on. Okay, I just want to make sure.
Don't worry about it.
When we're doing the geometric, remember, we're looking for a pattern where we can multiply by the same value to go from term to term to term to term. So, if it's not that, the other one that we did was what was called an arithmetic sequence, which was, you know, what can I add the same value term to term to term to try and get to my...
Are they here?
Yep.
Okay.
So, well, that's okay, because then they get into the pattern that a lot of... All right, so find the given term in each sequence, use the answers to solve the riddle. Now, I'm doing something a little bit longer today because I want you to get some extra practice figuring out how some of these things work. So my first job in this first one is to figure out what type of pattern, because they all have a pattern today. So in going from term to term, I always like to check add first, just to be sure. What do you add to 3 to get to 6? 3. Do I add 3 to 6 to get to 12? No. Okay, so it's not add. 3 times what gets me to 6? Times 2. 6 times what gets me to 12? 2. I think we have ourselves a pattern. Now, I don't want to make this real complicated, okay? So I look at this and I go, okay, they want me to find the 12th term. Holy cow. How many terms they give me? They gave me 5. So times 2 would be 6. Now, do I even need to hit enter? No. 7, 8, 9, 10, holy cow, 11, 12. Bang. Could I keep hitting times 2 every time? Yeah, but I might lose track, especially if it's a bigger number. This way, at least I've got 5, and I'm like, okay, and there's 6, 7, 8, 9, 10, 11, 12. Because, for instance, if I look down at the bottom, I see 6144 is one of the answers. But if I saw that what I got wasn't one of the answers, I could see what's going on right away. So, I don't know. So let's see here. What about number 2? Yeah, it looks like adding doesn't work because 1 plus 3 is 4. That doesn't get me there. But multiply, I agree. Looks like if I times by 4 each time. So like what we did before, they give me the first 5 terms, and I need to times by 4 to get the rest. So that would be 6, 7, 8th term. Bang. Oh, I don't hit. That's interesting. I'm just looking down below and I'm like, where's that answer? I don't see it. Somebody boo-booed. We'll come back to that one. Oh, okay.
I was just going to say that I don't think you did because there's no aspect. Right.
Oh. Nice. Okay.
Next one's 12.
Okay. Now, on the next one, can I add something or do I have to multiply again? Yeah, it looks like here, if I owe somebody $4 and then I only owe them 2, looks like I paid them 2 back. -2 plus 2, yeah, that'd be 0. 0 plus 2, yeah. So it looks like we're plussing 2 this time. Yeah. Okay, well, we will keep checking along here. You guys are on top of this today. This is good. So if I keep plussing 2, I want the 9th term. So there's 5, so that's 6, 7, 8, 9. Bam. 12. We got to find what's more challenging than this. I'm not going to answer what the answer at the bottom is. Yeah, I'm not answering. So let's see here.
I know.
What about... All right, there's two more I want to look at you on this side with here. I want to look at 6 and 7. Okay, 6. This looks interesting. Because if I'm looking at it money-wise, it's like $1 to $1.50 would be 50 cents. But then $1.50 to $2.25 would be 75 cents, so it's not add. What can I multiply 1 by to get to 1.5? Yeah, I can times by 1.5. Now, if you're like, I wouldn't think of that, we'll remind you of what we did yesterday if we weren't sure on one of these. I can take any two terms. If you take the second term and divide it by the term in front of it, that'll tell you the number you're multiplying by. And that'll work if it's a pattern for any pair. So like here, if I do 2.25 divide by 1.5, okay, I see the same patterns developing. So I see that that's going to be the way this works. So once I see the pattern, okay, I got 4 terms, and oh, I only want 5, so I just got to multiply one more time. So that's how this works. You can get some really funny looking answers, okay? It's absolutely possible. So do not worry about that. More interesting stuff. I think somebody pre-cut these pages together because I'm looking and I'm seeing some answers that just don't make sense. On 10, 1/3, -1/3, 1/3, -1/3. The only thing it changes is the sign. What could I multiply by that would just keep changing the sign every time? Yeah, it's just like I'm multiplying by a negative or a -1. Because if I multiply by -1, all it does is change the sign. So if that's the case, and they already gave me 5 here, so I'd have 1/3, that's my 5th term, times -1, so that'd be 6, times -1 would be 7, 8, 9, I'm going to stay patient, 10, okay, it's the negative. So -1/3, and that's at the bottom actually. Well, hot dang. So that's what we're up to on this side. I've got to figure out what the pattern is between the numbers and then keep using that to get my other terms. Now I push the envelope a little bit on the other side here. So let's flip over. Let me get my calculator out of the way. So for the first exercises here, determine if the sequence is geometric. Again, if I'm multiplying by something. If so, find the common ratio, which is a fancy way of saying find the pattern and then find the answer. So because of advances in technology, the value of a computer decreases rapidly. A computer that's worth $1,000 when purchased could be worth $800 in 6 months, $640 in a year, $512 in 18 months, and $409 in 2 years. Okay? So we want to just find the pattern here. So let's look at the numbers for a second. So we go from 1,000 to 800 to 640 to 512 to 409.60. So let's try our method before to see if there's a pattern running here. So I can take any two numbers in the list and start working my way through. So let's say I do 800 divided by 1,000. And I don't like decimals, so math enter enter. Now this says my rule would be I'm going to multiply by 4 over 5, or 0.8. Now let's see if that works if I do another one. 640 divided by 800. It's always the number after it divided by the one before. Yep, 0.8. 4/5. And so when there's an actual geometric pattern, you see the same thing develop. So basically, it's going down by 4/5 each time. Okay? So you're multiplying by 4/5. It's going to keep shrinking and shrinking and shrinking and shrinking in value. And that's how I'd figure this out. So let's see here. Now this next one, we got to figure out if this would be geometric. Starting weight was $6 an hour. Holy crap. She's told that she can expect a 25-cent raise every 6 months. So if this keeps going up by 25 cents each month, well, each 6 months, excuse me. So I just kept adding a quarter. Am I multiplying by a number? No. Okay, each of these times I'm adding. So that would be arithmetic. So this one, that's not even geometric. Okay, I've got to figure out if it's geometric. Well, that's not. And so all I'm doing on these story problems, and I'm actually going to do the next couple with him. I'll do one of the ones down below, and I'll set you on the rest. Piece of paper that is 1/100th inches thick is folded in half repeatedly. If it's folded 6 times, how thick would the result be? Okay. So I start with 0.01. Folded in half. How would I punch that into the calculator? What's a way of getting half of something? Okay, I can either multiply by 0.5 and I had to do this 6 times. Okay, so instead of doing it this way, let's do this. So that's 2, 3, 4. Wait a minute, I want to read this again. Let's get a piece of paper out. I'm going to use this note card. Okay, let's say this is my piece of paper that I have. If I fold that in half, and I'm looking at the thickness of my card now, did my card just get thinner or thicker when I folded it in half? Okay, it got thicker. So if I look at this for a minute, is it getting thicker? Is that number getting larger in value? That's getting smaller, so wait a minute, we got to make an adjustment here. If it's getting thicker, instead of multiplying by 0.5, what might be a better idea if it's getting twice as thick? Because every time I'm folding this, okay, now it's 4 times as thick. And then I fold it again, and it keeps getting thicker and thicker. So instead of timesing by a half, what should I times by? If it's getting twice as big each time. Yeah. Instead of timesing by 0.5, okay, let's times by 2. And this is starting to make more sense because now that value is getting greater. Even if I looked at it like it was money, it'd be like a penny, 2 pennies, 4 cents. And keep working that out. 6 times. So let's see. 1 fold, 2 fold, 3 fold, 4 fold. Whoa, not 0.2. 5 fold. 1 last fold. Okay, a little over a ½ an inch thick. Doesn't seem like much. But again, nothing too bad. So 0.64 is how thick that would be. So let's see. How am I supposed to know this? Ooh, we get the abstract one at the end. Okay. A vacuum pump removes 1/2 of the air in a container with each stroke. how much of the original air is left in the container after 8 strokes? You're like, well, it doesn't tell me how much is there to begin with. Well, we'll just say that it had 1 of something to start with here. If I'm removing half each time, now we're into what Taylor was talking about before. Yeah, now we're going to times by 0.5. It's just looking at numbers and being able to understand the patterns. So, okay, 8 times. So that'd be once, twice, 3, 4, 5, 6. Holy cow, there's not going to be much left. 7, 8. Yeah, not much. I was going to say, with that much air, you can basically say there's no air left in it, because we're timesing by the 0.5 each time. And then down at the bottom, we're going to be figuring out tuition at universities. Now, it's going to be the same for each one of these, so once we get the first one, we'll have the general idea. This is going to be the end. Yeah. Yes. Yeah. So, when you get one of these, okay, it's going to increase by 5% each year. Now, so for instance, if it goes up 5% each year, let's get the calculator up. All right, 2256. How do I find a percentage of something? How do I turn that into its decimal form? Maybe we need to figure that out first. If you have all of something, what percentage of it do you have? So if you have a pizza and you have all of it, what percentage of the pizza do you have? 100. So if I take the 5% and divide it by 100, okay, so that 0.05 means that's what I have to add. Now, if some of you want to make this go a little bit quicker, because you're like, what you'd have to do here, and then I'm going to show you a shortcut, is I'd have to add this. Okay, so that's how much it would be after 1 year. It would be this. And then you would have to do that for every year up to 10 years. That's going to get a little tedious. So, here's what we're going to do. We're going to go back to what we just got done with, because it's growing by the same part, so it's like growth. So here's what we're going to do. We are going to clear this out. There's going to be my starting amount. So let me get this jotted down here. You're like, why are you putting y equals? I'll explain in a minute. It's going up by 5%. So if you remember back to when we were just doing growth and decay, I can put 1 plus 0.05. And what do I want to know? I want to know what tuition's going to be in 10 years. So I can use my growth. And again, that 10's an exponent, so I got to use the little caret button right here. No, that's supposed to be an arrow. My arrow didn't show up real well. And you'll notice the answer I get in one step is much better. Much better. And then the one other hint I'll give you, because the setup will work exactly the same on this for number 6 and number 7, I want to give you a hint on number 8. And then I will officially get out of the way here. On number 8, of course, I need to have done something with number 7 first, because you're like, if you started attending Northwestern in 5 years, you're like, well, how much will I spend? I don't know. Oh, okay. So Northwestern there's two parts to this. The first part, I've got to figure out what Northwestern cost in 5 years. Okay. Then, now this is the part that gets interesting. This is the part where there's a little bit of work. Once I know that, I have to do a 4-parter here. They're like, seriously, Hardy? Yes. 4-parter. I have to find out how much this is going to cost, because it says total. I need to know year 6. I need to know year 7. This person's going to spend a lot of money. Year 8. No, because 0.5 would be 50%. Oh my gosh, I'd never be able to afford college if it was going up 50% every year. And then I add all them up, and that'll be one of my answers. But at least that's a nice setup for you to get going with. I know. Okay, so tasks today. Try and knock out the other problems on this sheet when there's not a lot of them left. Get that in. And then if you haven't gotten far enough or you're still working on yesterday's, to kind of work on that. Because tomorrow we're going to go full-fledged into review mode for this unit test that's coming on Thursday. That's where we're at.